Good morning, class. Welcome back. So we shall complete the last two questions of exercise 12.2. So this is the question given, okay? A round table cover has 6 equal designs as shown in figure if the radius of the cover, okay? So from the center of the point, the radius of the cover is given as 28 centimeter, okay? So this is, so all of this in the sense you can write this as 28 centimeter. This is the radius, okay? And then what is given again is that they have also given that they have 6 equal designs. So you can actually divide this given tablecloth, okay, let's say round table cover, into 6 equal parts. Again, all of this line will be this will indicate the given radius because it's from this point to this the end of the circle, right? So that becomes the radius, okay? So we're actually asked to find the cost of making the designs at the rate of 0.35 per centimeter square. So for this, let's first write down what we have, okay? Let's write down all the inputs. So we have the radius. The radius is given as 28 centimeter. Okay, now you look at this. If I take a turn from here, okay, I take a complete revolution and I end it here, that I will get 360. Clear? And this angle will be 360. This a complete revolution if I take a complete round like this, okay? Even in the case of this, from here if I start and I take a complete revolution, okay, I finish this complete, it will give me 360. Even for the case of this, even if it's straight line, I start from this point and I take a complete revolution like this and I reach this point, this given angle, the given angle of this round area will be 360. Clear? So you see, you look at this, they are divided into 6 equal parts. That means 1, 2, 3, 4, 5, 6. Okay, write this as 1, 2, 3, 4, 5 for better understanding. So if I take a complete turn from one of this given area and then I take it, I encircle it, and I end up reaching the same place again. So I'll get the angle, okay, formed. So I'll just name these angles, various angles as theta. So from this theta I take, okay, I cover through all the remaining 6 thetas, I'll be getting it at a 360 degree, okay, the total revolution of that in the sense, okay. So see, 1 theta, 2nd theta, 3rd theta, 4th, 5th, 6th. So if I cover all these 6 thetas, I'll end up getting a degree which is 360 degree. Clear? A complete revolution will give you that. So you have theta into 360 degree by 6. So theta is equal to 60. Okay, clear? So you can just erase theta now and you can write this as 60 degree because all of them are going to be 60 degree each. Okay, 60. Okay, these are all going to be 60 degrees such that when you add them or you multiply them with 6, you'll end up getting 360 degree. Now let me consider one triangle. I'll consider this triangle A, B, and okay. So let me consider this center point as 0 and this as P, okay? So A, B and O is a triangle, A, P, B is another triangle. We're asked to find the cost of making the designs, okay? So the design, so this is the design we're talking about, okay? This area is the design, okay? Only this area, because see, the other part is all plain. There's no design for this plain surface, right? So only this design we're talking about. So if you just focus on this is a segment, right? This is a segment. So you get an idea of what we have to find. Clear? So but before that, let me focus on, bring your attention to triangle AOB. You look at triangle AOB, this is 28 centimeter and this is 28 centimeter. Triangle AOB is an isosceles triangle. Okay, it's an isosceles triangle. So why is it an isosceles triangle? Because it has 2 equal sides. It has 2 equal sides. What are those equal sides? It is AO and OB is both equal to 28 centimeter. And as such, we'll have 2 equal angles. Okay, we'll have 2 equal angles. Clear? Equal angles. Now I'll say, see, we already found out that this is 60 degrees, so that means angle A and angle B will be same. Okay, so the 2 equal angles, I'll call them as angle A and angle B. I'll say the 2 angles are angle A and angle B. Okay, they'll have 2 equal angles. Okay, clear? Right now for this, we'll take it this way. Okay, so what do you understand by sum angle property? Sum angle property tells us that the sum of the 3 angles of a triangle, that means angle A plus angle B plus angle O, will be equivalent to 180 degree. Now angle A and B is equal, so I can write this as angle A plus angle A. Angle O is equal to 60 degree, which is equal to 180 degree. So you have this as 2 of angle A. So take 60 to the other side, so 180 degree minus 60 degree. So 2 angle A, this becomes 120 degree. Clear? So angle A will be equivalent to 120 degree divided by 2. So angle A is equal to 60 degree, and it is also going to be equal to angle B. But what we do, we also know that angle O is 60 degree. Therefore, triangle AOB is an equilateral triangle. Okay, this is how we prove that it is an equilateral triangle, as they have equal angles. Clear? Equal angles. So if they have equal angles, it also implies that it has equal sides. Okay, we'll be using this. Therefore, we can say, therefore, area of the design is what? Now you go back to the design. What is area of this design? It looks like a segment. Remember the red line that you can see. This is a segment. We're asked to find this design. So this is look like a segment, right? So in order to find a segment, what formula do we use? We used area of sector minus area of triangle AOB. Now area of sector formula is theta by 360 into pi r square. Area of a triangle, since it is an equilateral triangle, we can actually use the area of an equilateral, which is 3 by 4 side square. Alright, so theta is given as 60 degree. Pi, you can take it as 22 by 7. The radius is given as 28 centimeter into 28 centimeter minus, they have specifically told us to use root 3 value as, look at this, root 3 value as to 1.7. So root 3 value is 1.7 divided by 4. Side, it will be 28 centimeter into 28 centimeter. So 4 into 7 is 28. 7 into 4 is 28. Cancel 0, 0. 6 into 6 is 36. 2 into 3 is 6, and 2 into 11 is this. So you'll have this as 44 into 28 centimeter. So centimeter square by 3 minus 1.7 into 7 into 28 centimeter square. So I'll write it as centimeter square. Clear? So you can start doing the okay, you can actually do this here, okay, the calculation. Okay, so in order to ease up our work, let's say I'll take 28 common. Clear? So I'll just take 28 common, so I'm left with 44 by 3. Okay, because 28 is common to both, I'm just doing this step to ease up our calculation. So 1.7 into 7 will be left. Now since centimeter square is again common, so you take this. So you see 44 into 3, it makes our work easier. 3 into 1 is 3. 3 times 4 is 12. So you're left with 2. You put a 0 here. So 3 times 6 is 18. 3 times 6 is again 18, and it will continue. Okay, and 3 times 6 like this. So you're getting this as 28. I will approximate 44 divided by 3 as 14.67. Okay, minus 17 into 7. 1.7 into 7 will give you to 11.9. Okay, 11.9 centimeter square. So you subtract 14.67 minus 11.9. What do you get? You'll end up getting this as 28 into, you'll get it as 2.77 centimeter square. So you multiply this, okay, and so you'll finally get this as 77.56 centimeter square. Therefore, see, we have found out the area of only one of the design. Okay, see, we have found out only for one design, only this design, but we are asked to find the cost of making the designs by the word, by the see, as itself, it's understood that we're talking about all the designs, right? That means we have to find all these areas also in the sense. But okay, you understood, we found only for one, so we still have to find the remaining. But what do we know? We have that the designs are equal. Okay, that means whatever value we found for this, it will also be the same for this, for all the remaining designs. Clear? So the total design, how to find the total design? So the total design is going to be equal to 6 into 70, because there are 6 equal parts. So you'll have to multiply them with 6, or you'll have to add them 6 times. That means 77.56 plus 77.56. You'll have to multiply them 6 times. Clear? You have to add them 6 times or multiply them. Okay, multiply them with 6. So 77.6 into 6 will give you 465.8 0.36 centimeter square. Therefore, the cost of the designs, okay, cost of the designs. So the cost of the designs will be the total design into cost of the design. So the total design, the total area of design, okay, it's not total design, total area of the design, clear, is going to be 465.36 centimeter square. The cost is given as rupees 0.35 per centimeter square. Now let's see, 46536, I'll put 100 here. Okay, let's try to omit the decimal points. Into 0.35, can I write it as 35 by 100? Now the significance of per centimeter square is when you multiply it per centimeter square. Remember, okay, every time you see the word per centimeter square, what happens is that centimeter square will go to the denominator, clear? So suppose you're given 10 per meter square, so it's understood it is 10 by meter square, clear? Alright, so usually 10 per meter square, or people write it as 10 meter like this also, okay, it's possible. But the word per, what happened, okay, remember per means meter square will go down to the denominator, okay, clear? So centimeter square will cancel. So you see 46536 into 35 will give you 16,28760 by how many zeros? 1 2 3 4, and then there's rupees here, so you write rupees here. Clear up to this much? Centimeter square, centimeter gets cancelled. So finally you can write this as, now you can write this as 4 decimal points. So rupees 162.4 decimal, so 1 2 3 4, so after this 8760, clear? So the answer will be rupees 162.87. You can write this, and okay, now see, remember in your textbook answer it's given as 162.68, clear? But this is not the exact value, it's just the approximate value, okay, clear? So you can, this is also a valid answer. 162.87 is also a valid answer. Since we're not talking about, you can write this as approx value, okay, not exact value, clear? So if you're not so satisfied, you can consider this 14 point, instead of 67 you can just consider this as 14.66, okay, and you can do the calculation again. All right, okay. So when you do in suppose I'm just saying, instead of 14.67 you take it as 14.66, okay, so you'll be getting this as 28 into 2.76, okay, into 2.76, or so you'll be getting this as 77.28, clear? Alright, it depends on what values you're taking after approximation, okay? You can take it as 14.66, you can take it as 14.67. It's not really a problem, okay, clear, since we're talking about the approximated value. So the last question is this: area of a sector of an angle P, solution. So what do we know? We know that the radius is given as capital R. The angle in the sense theta is given as P. Now what is the area of a sector? Just write down area of a sector. What is the formula? Area of a sector is theta by 360 pi r square. So you can write this. What is theta? Small p divided by 360, and what is small r square? Is capital R square. So now you look at this. Can you consider this? No, you cannot consider this, okay? This is, see, at least just focus on r square. In this option there are only two options which has r square. One is this and this, right? R square. So option C and A is already out of question, clear? Now you look at this, you're getting this as P 180 P by 180 2 pi r square. So is this the formula? No, this is not the answer, because you're supposed to get it by P by 360 pi r square. Now you look at this, what happens? Now you cancel out 3. Now you see, you cancel out 720 with 2. 2 3s are 6. 2 6 are 12 and 0. So if you cancel them out, option number D is actually the same thing as P 360 into 2 pi r square. Clear? If you cancel out 2 from here, sorry, it's the same thing as small p by 360 into pi r square. Because why is this so? Because when I cancel out 2 with 720, I get 720 as this. That means, let me just write here, okay, P by 720 into 2 pi r square. You cancel out with 2 into 3 and 360, so you're left with p pi r square by 360. So you end up getting the area of a sector, which is this. That means the correct option is going to be D. Clear? This is going to be option number D. So we'll end the video here, and I'll start with the next exercise in the next video.